Okay, we have 2 points here. Point A, which is -6, -3, and point B, which is -2, -5. And we're asked the question, what is the displacement vector that moves point A onto point B? And what would be the displacement vector that would take point B and put it back onto point A? So let's take a look here. From point A to point B, we'd have to go down 2 spaces, and looks like, so down 2 and 1, 2, 3, 4 to the right. So the displacement vector would be 4, -2. To go in the other direction, from B, we'd have to go, let's see, back 4 and up 2 to get to A. So the displacement vector in the return trip would be -4, +2, which is the opposite of the first vector. That kind of makes sense, since whatever journey I took from A to B would be the opposite of the journey I would take back from B to A. Now, let's imagine that you couldn't actually plot these points, because for whatever reason you didn't have the graph or couldn't graph it. You can calculate this anyway, just using the coordinates. One way I would do this is I would line the points up, and I would do point A, -6, -3. These are my x and y coordinates. And point B is -2, -5. Okay. So going from, let's see, depending how you want to set this up, but if I'm going from A to B, then it's always end minus start equals change. So I go -5 minus -3. And over here, end minus start equals change. -2 minus -6. -2 minus -6 is a +4. And -5 minus -3 is a -2. So there's our displacement vector going from A to B. Other way around, I would just subtract going the other direction. So end minus start equals change. Just line up the coordinates and do the subtraction if you want to find the displacement vector.